So, hello, welcome to Nixo's Discovery. We're going to. Oh, yeah. Okay. Cats saw a bird at the window, so they that's their TV. uh, the window behind me. So, a package with dependencies. Now you will package a somewhat more complicated program. So yeah, last time I packaged a hello.nix, a GNU hello, and the program itself had no dependencies that we had to call. So this time we're going to do a package with dependencies. So a more complicated program, iCat, which allows you to render images in your terminal, changed the default.nix from the previous section by adding a new attribute for iCat. Not sure if we already did that last time. So default. Okay, it's here. All right. It's the same as with a hello. So yeah, this is kind of clear. So the LED binding. So there is the Nix packages and then the packages, and probably my wording gets like, but we can add more packages here, right? So we have the hello, the iCat, and everything else, and it all connects to these parameters and in the head of the LED, I guess you could say, the head of the LED. All right, yeah, this is it's something about functional programming, and I've been learning this for so long. But I think the very important thing is to really know how to use words when you describe things, because words have meanings. And then, because once you get to deeper meanings, if I'm getting lost. All right, I'll just do the tutorial. Now we will package a somewhat more complicated. Okay, change the default. We did this. Copy hello nix to a new file, iCat nix, and update the pname and version attributes in that file. All right, so we copy the hello.nix into icat.nix, right? Now we have icat.nix, and let's. Oh, I think we have to icat. And yeah, I still haven't worked on my Helix skills. VO5, which I should. VO5 source fetch zip. Well, I guess I have to what? X. Okay, I can do this. So fetch zip. Now to download the source code, iCat's upstream repository is hosted on GitHub. Okay, so because GNU Hello was on some FTP GNU Savannah, or I don't know. Yeah, I remember the name. Okay, so you should replace. You should. Whoa, I have to just close the window. All right, so you should replace the previous source fetcher. This time you will use fetch from GitHub instead of fetch zip by updating the argument attribute set to the function accordingly. Fetch zip. All right, let's see. Fetch from GitHub. So we have to declare it here, and then put it here in the body. Standard environment. So this is all the same. So let's go. No. Fetch from GitHub. Fetch from GitHub, yeah. It's like this. Fetch from GitHub. And we have the lib here. So yeah, that's the PR actually that we reported, that I reported, because we're putting lib in the parameter set, but then we're not calling it here. So even though the program actually works, the editor keeps on showing. If you do it like it's showing now also something unused binding fetch from GitHub. Oh yeah, unused binding because we still didn't put any option. But you see, like if I put lib, it says unused binding because I have no lib function. Before we used it so that we can use lib fake SHA to get the SHA, but now you see we don't need it here. The source URL is GitHub ATEX store icat, which already gives the first two arguments, owner and repo. So we need like here we need owner is ATEX store and repo is what? What's the repo? icat. All right. So will it show now the fetch from GitHub undefined name? Why is it showing undefined name? Fetch from GitHub. Oh, a typo. Now it's fine. Fetch from GitHub. But you see the lib keeps on showing undefined, unused binding. So I filed a PR where we remove that, right? Now the interesting thing is when I file, I'm still not sure what is the reason for this. Yeah, here is it. Lib unused binding in hello.next. So we apply lib fake SHA to get the right hash, but upon removing it, the lib in the argument set becomes an unused binding. So now I'm not sure, like, should we delete it? Yes, probably yes. Should there be something written in the tutorial that explains it? Not sure. So later in hello.next, yeah, it's copied into icat.next where the unbinding issue remains. So I guess maybe I could just, yeah, it still shows it. Commits, files change, edit. Could I like edit it? No. Code, check out code spaces. Like how do I could review changes. Can I do that? Review changes. Like let's say if I review in code space, could I review in code space? You see, I just want to display comment on this file, edit file, maybe with edit file. All right, let's see. Okay, maybe I can, yeah, okay. New hello. So we have, so this is how you can basically contribute to the documentation. Hello.next lib standard name. So here we needed it. Then we don't need it. Wait a second. Hello.next SHA. So here I removed it, right? I think it's here. Yeah. Build result, package with dependencies. So, and here, hello next to a new file, icat. Right, we don't need the lib. So let's remove that. Let's remove that lib icat.next. Let's remove this lib. Fetch source from GitHub. console lib icat.nix sha here. Let's remove it here as well. Name missing dependencies. Compiler error icat. Oh, that's a lot of removing. Repo sha build inputs. Oh. Well, let's see. Let's just commit changes. Commit changes. Oh, this will be a new one. Oh, add an optional extended description. Wait, let's cancel. Okay, discard. Maybe check with the team. All right. So this is my. Oh no, it's not here. Where is it? Kind of sometimes I'm still not like unused binding. Wait, let's check with the team, right? Go to Nix documentation again, Nix documentation. There are more. Should we delete this? Should I delete this? Should we, is this supposed to be deleted? And then in the icat.nix, the unbinding remains as well. So is this supposed to be deleted? In the issue remains in the icat.nix. So sure, if it's maybe convention, or I'm not sure if. So I'm not sure. Is the lib supposed to stay throughout the tutorial? The lib supposed to stay throughout the tutorial? It's only used for the fake SHA. All right, so now I've checked with the Nix documentation, the matrix channel, and already someone saw it. So probably they're gonna, you know, I'm probably gonna get something back. All right, so let's continue. Okay, we have this. So navigate to the project's tags page to find a suitable Git revision, such as the Git commit hash or the tag corresponding to the release you want to fetch. In this case, the latest tag is v0.5. That's basically these tags, 0.5, or the hash, which would be this number here. All right. In this case, the latest tag, the release tag is v0.5. As in the hello example, a hash must also be supplied. This time, instead of using lib fake SHA and letting Nix build report the correct one in an error, you can fetch the correct hash in the first place with the Nix prefetch URL. You need the SHA-256 hash of the contents of the tarball as opposed to the hash of the tarball file itself. Therefore, pass the unpack and type SHA-256 arguments. Someone writing anything? No, it's not. You need the SHA. Okay, so we're going to use the Nix prefetch URL tool. That's like a tool, yeah. Unpack. So what do we need? You need the SHA. Pass the unpack and type SHA arguments. All right. Oops. No, wait. Let's delete this, right? So we're gonna use nix prefetch unpack. Oh, I already did this. Unpack HTTPS. All right, type SHA-256. Let's just, okay, downloading, and we have the SHA. Copy and set the correct hash for fetch from GitHub. So we're gonna write the revision number. The rev, what's the rev? v0.5. And the SHA-256 is this one. And that would be it. Missing dependencies. So now we're gonna run nix build with the icat attribute. So entirely, so let's see what's gonna happen. So we're gonna run nix build. We're gonna run nix build a icat. So let's see what happens. Nix build a -a icat. So it's taking a bit. Let's see if they already responded something. No. No. Why is this taking so long? It's taking long. What is it doing? Oh, these two derivations, fatal error. Probably was trying to check. Maybe if I put like trace or something. Verbose. Is there something like that? Verbose or something. Yeah. Okay. I was trying to compile it. Yes, that's why it was taking so long. Okay, so icat. So we have this no such file or directory imlib include. So this is some kind of a dependency. Imlib2, imlib2h. So imlib2h, a compiler error. The icat source was pulled from GitHub. Great. And Nix tried to build what it found, but compilation failed due to the missing dependency, the imlib2 header. If you search for imlib2 on search nixos.org, you'll find that imlib2 is already in Nix packages. Oh, I like this. Sometimes like I want to name my links that I would write like search for imlib on, and then I would link this. But this is much better. Like you do the search and then you link the result of the search with a description as a link. I have to remember this. This is kind of nice. So you see, you already get here. But yeah, it's cool. Okay, imlib2 image manipulation library showing results. So this is great way to look for packages and NixOS options, right? Add this package to your build environment by adding imlib2 to the arguments of the function in icat.nix, then add the argument's value, which is the name itself, imlib2, to the list of build inputs in standard environment mk derivation. So that goes into build inputs. So we're gonna write, so we need to write here imlib2, right? Standard environment, imlib2, and we need build inputs. So it's showing, see, it's showing it's not build imlib2, right? So that's okay. So run nix build a dash a icat again, and you'll encounter another error, but compilation proceeds further this time. All right, let's do it again. Verbose. Let's try without verbose. So nix build dash a icat, copying path, downloading. So this looks like we need another dependency. So it's going, yeah, it's going like step by step, right? So we need x11 xlib.h, xlib. You can see a few warnings which should be corrected in the upstream code. But the important bit for this tutorial is fatal error. There's no such, another dependency is missing. Finding packages. So determining for where to source a dependency is currently somewhat involved because package names don't always correspond to library or program names. You will need the xlib.h headers from the x11c package. The nix package's derivation for which is libx11 available in the xorg package. So that's the xorg package set. There are multiple ways to figure this out. So the easiest way to find what you need is on search nixosorg packages, as we did. Unfortunately, in this case, searching for x11 produces too many irrelevant results because x11 is ubiquitous. On the left sidebar, there is a list package set, and selecting sorg shows something promising. Yeah, but what if I just, can I just like look for this? So copy, and I go to packages, and I look for this. Oh, no packages found. So it cannot look for this like with a slash. So if I look for xlib.h, no packages found. Oh my. So I have to look for x11, and there's so many packages. But if I go to xorg, and then I get it here. Oh, I cannot look for it with a slash. This is interesting. So wait, here it's written with a slash, and yes, because it's like a file path. And nix packager, I mean, when you look for like sets, they have a dot. So wait, would it find it if I just put a dot? libx11. No, wait, xorg. x11 xlib.h. Wait. x11 dot xlib xlib.h. No, xlib.h. No. Does it? Is this important? xlib.h. No. This is interesting. It would be nice that if, wait, libx11, I'd found it like that. libx xlib.h. Yeah. Well, so, yeah, okay. libx. Okay. So let's return. Searching for x11, too many relevant. Yes, on the left there is a package set, and selecting sorg shows something promising. In case all else fails, it helps to become familiar with searching the nix package's source code for keywords. Local code search. So to find name assignments in the source, search for keywords. These are the search results for x11 or libx11 on GitHub, or fetch a clone of the repository and search for the code locally. Start a shell that makes the required tools available, Git for version control, and RG for code search, provided by the ripgrep package. Nix shell. Okay, I already have this installed, but let's just do it like nix shell. So we go to nix shell, and we get git and ripgrep, and it's gonna get it now. Right. So the nix packages repository is huge. Only clone the latest revision to avoid waiting a long time for a full clone. Yeah, I did this with a full clone, and it really takes a while. like 4 gigs. But this is a cool, like you could just like, okay, git clone, https, github.com, and nixos. So you need to know how to type this, nix packages, and the depth, right? Depth 1, I guess that's the first revision. So cloning into Nix packages, this is much quicker, faster. Yeah. So, and deltas, back reused, updating files. Damn it. Updating files. Okay, so we have it here, right? Look, Nix packages. So we cd into Nix packages, and we are in Nix packages. To narrow down results, only search for packages subdirectory, which holds all the packages, all the package recipes. So we do rg, like ripgrab, yeah, rgx11, rgx11 equals packages. So this is a lot. Wow, I mean, it looks nice, but this is too much. Whoa. Packages, packages tools, x1 prompt default.nix. So did it look for this, or I'm not, this is, oh, this is probably, wait, let's stop this thing. Packages tools, is this a mistake? A mistake, like a, it just, RG equals, what did I write here? Like this. Oh, all right. Packages top level, all packages.nix, RG. All right. So yeah, this is a lot. Maybe it's not so much, but it's some noise. Since RG is case sensitive by default, add -I to make sure you don't miss anything. What does -I do? To make sure you don't miss anything. So it's about case sensitive. Let's see if someone wrote something. Tricklerhand wrote. Tricklerhandwerk. Yeah, maybe they're busy. No, it it is Monday, and I'm like, yeah, okay, but let's not rush things. That's important, not to rush things. Since RG is case sensitive, so we can do a dash, right? We can do a -I, and there's still noise. Wait, okay. -I, packages. Oh, but I'm doing the libx, right? The libx, libx 11. Okay, let's do this. Okay. Superlib override address call package. So here is it, right? That's what we are looking for. Hello. Yeah. Local derivation search. To search derivations on the command line, use nix locate from the nix index. Yeah, how do you do that? Nix index. Do we have nix index? What's nix locate? It's not in your path. Nix shell p nix index. So we need to nix.shell p nix index. So let's see what this does. Nix index. All right, we have nix index, and now we can use nix locate. Nix locate pattern. Nix locate So the problem we had, the missing libx. Let's do a libx. From the database, next index to generate. All right, yeah. Querying available packages. So now with Nix index, we're generating the database. This is like TLDR or something when you update querying available packages. Did someone write something? No. All right, let's see. Adding package sets as dependencies. So this is like the entire set as dependency. All right. Add this to your derivations input attribute set and to build the inputs. Lib standard environment fetch from GitHub imlib to and xorg. So we're gonna add querying. This is still still indexing. Yeah, I guess okay. I guess I'll just stop this. Yeah, I'll just stop it. I'll go out of this shell and out of this shell. So we were now 2 shells deep. It was kind of Nix shell inception. So we're gonna go to icat and add the xorg package set. Owner shall build inputs. Okay. Oops. So what happened? Ooh, I didn't want this to happen. Mlib xorg libx 11. Yeah, that's the build inputs. Also, only add the top level xorg derivation to the input attribute set rather than the full xorg libx11, as the later would cause a syntax error. Because Nix is lazily evaluated, using xorg and this subset, right, means that we only include the libx attribute and the derivation doesn't actually include all of xorg. So yeah, it's going like from bigger to smaller, right? So you as a parameter you declare the entire xorg, and then you use this thing here, and here is just kind of referenced. So now it should work, and maybe let's build it, see what happens. Do we have to build it? I think we do. So something's missing. Error. But this is ignoring return shell. Use default source function main. Oh, this icat scene function main running phase install. No rule to make target install. Stop. Install flags. Install phase. So we compiled it all right. It seems like we compiled it, but the install phase somehow something didn't work. So run the last command again. We did that. The missing dependency error is solved, but there is now another problem. Make no rule to make target install. Stop. Yes, this one. Make no rule to make target install. Stop. So install phase. Standard environment is automatically working with the make file that comes with icat. The console output shows the configure and make are executed without issue. So the icat binary is compiling successfully. The failure occurs when the standard environment attempts to run make install. The make file, including in the project, happens to lack an install target. The README in the icat repository only mentions using make to build a tool, leaving the installation step up to users. To add this step to your derivation, use the install phase attribute. It contains a list of command strings that are executed to perform the installation. So we need, so we had the build, we had the build, we had the build inputs. We don't have the install phase, right? So this was getting the thing. This was building the thing with the dependencies that we need. And now with the install phase, how do you install it? Because make finishes successfully, true, the iCAD executable is available in the build directory. You only need to copy it from there to the output directory. So this part always confused me. It's like, yes, I get this, but sometimes I would get confused. Like, how does the Nix tricks? How does the Nix tricks the build environment? Because I guess the make wants to do stuff with um, FHS, the Linux directories and all that stuff, and Nix is so revolutionary. So I think it kind of tricks the whole build process, makes some kind of a simulation thing, and just copies it to store. And next, the output directory stored in the out variable. All right, that variable is accessible in the derivations builder execution environment. Create a bin directory within the out directory and copy the iCAD binary there. So, right, this is like next derivative. So the builder is executed. All right, here is like written probably all the detail. Temporary directory is created under the directory specified by temp directory. Those the default temp. Oh, that's like sometimes where stuff are built in the temp, where the build will take place. Right. And in usually, I guess temp is the place where it automatically gets deleted in the Linux, right? Because temporary, right? The current directory is changed to this directory. So, but Nix does not have a temp directory, right? Oh, but the temporary directory is created under the directory. The environment is cleared and set to the derivation attributes as specified above. The following variables are set. Nix build top contains the path of the temporary directory. Nix build top. Temp dir, temp are also set to point to the temporary direction. Path is set to path not set to prevent shells from initializing it to their built-in default value. Home is set to homeless shelter. Wait, this is funny. I didn't know this. Home is set to homeless shelter to prevent programs from using Etsy password or the like to find the user's home directory, which could cause impurity. Homeless shelter. Usually when home is set, well, it's not funny, but still, I didn't expect this. Home is set, it's used as the location of the home directory even if it points to a non-existent path. Homeless shelter. And Nixstore is set to the path of the top level Nixstore directory, Nixstore. Yeah, so I mean I understand this, but then when I'm out of this, I still like conceptually I know, but I can't see how all this happens. Homeless shelter. Well, and next the output directory is stored in the out. Create a bin directory within the out directory and copy the iCAD binary there. Okay, so let's do the install phase, right? So the install phase, we're gonna write install phase, and now we have a multi-line string, right? mkdir make directory p what's it out and bin, and now we have cp iCAD when it's built into out bin, right? Yeah, so that's it. Just need this. So what happens when we run Nix build again? Running fix up phase. Seems like install phase was fine. Fix up phase shrinking. shrinking, checking, patching, stripping. And we have a derivation. Oh, wow. Look at this. Next door. Is this done? Phases and hooks. Next package's standard MK derivation are separated into phases. All right? Intended to control some aspect of the build process. Earlier you observed, let's see if someone wrote something. No, maybe they're busy. How standard MK derivation expected the project's makefile to have an install target. Fail when you didn't. To fix this, you defined a custom install. Right. To fix this, you defined a custom install phase containing instructions for copying the iCAD binary to the correct output location. In fact, installing it up to that point, the standard environment MK derivation automatically determined the build phase information for the iCAD package. During derivation realization, there are a number of shell functions, hooks, which may execute in each derivation phase. Hooks do things like set variables, source files, create directories, and so on. These are specific to each phase and run both before and after the phase's execution. They modify the build environment for common operations during the build. A moment. Good practice when packaging software with Nix to include calls to these hooks in the derivation phases you define, even when you don't make direct use of them. This facilitates easy overriding of specific parts of the derivation later, and it keeps the code tidy and makes it easier to read, adjust the install phase to call the appropriate hooks. Yeah, I did hooks. Shell functions or hooks, which may execute in each derivation phase. Hooks do things like set variables, source files. So what do these run hook pre-install? What's the run hook pre-install? The run hook pre-install. What does run hook do? Why are some pre and post phases not enabled by default? Yeah. Why? So it's interesting. Once you just dig into it, the default package build phases are unpack pre-phases. Unpack phase, patch phase, pre-configure phases, configure phase, pre-build phases, build phase, check phase, pre-install phases, install. Oh my god, that's so many. But builds also commonly include phases like post-install, pre-fix-up, post-fix-up. These are often activated manually by running runhook pre-install. All right. One common problem I run into is that I want to modify one of those phases when overriding a package, but I do not know if it is being called or not. Why are these called that way and not activated by default? Why are they usually called manually using runhook instead of adding them to the phases array? All proper expressions based on standard environments should explicitly run hooks. When their phases are overridden, the hooks need to be run explicitly because the standard environment generic builder runs the pre and post phase hooks in the default definitions of the phases. So when the phases are replaced, there would be nothing running the hooks. It's not ideal, but changing it now would break backwards compatibility. Oh. Hammering. What's the hammering repo? Explanations. Oh, wow. G. Tojnar. I know this name. I saw it. He's probably one of the committers. Oh, if you're overriding configure phase, build phase, check phase, install phase, you should not forget about explicitly running pre and post phase hooks like their original definitions do. Your commands before. Okay, so install phase, that's what we did first. And after install phase, run hook pre-install your commands, run hook post-install. Yeah, it's still Nix package is hammering explanations. Oh, this is nice. There are many idioms in Nix packages which beginner packages might not be aware of. This is a set of nitpicky rules that aim to point out and explain common mistakes in Nix packages, package pull requests. This repository contains a bunch of overlays. Oh, this is nice. I have to check this. This is nice. I'll star this. Yeah, you're gonna get a star. And I'll save this. I'll save it in Nix. I should study this a bit. Yeah, all right. So run hook pre-install and run hook post-install. I guess icat.next. So run hook pre-install. Pre-install, yeah, so always camel case. Post hook, run hook, oh, run hook, post install. So let's try to build it now. And but wasn't it the last time successful? Wait, what did it build? Let's see what it did build. W6A7. Let's check the hash. Oh yeah, it's a different hash because we changed the file. Right, so every time when you change something in the derivation in the next file, the hash should be different even if you add space. That's the other cool, really interesting things about content addressed derivations. This is kind of an experimental feature that where you would still have the same hash if you do a change because its hash is based on the content, not on the input. Yeah. A successful build, running the next build command once more will finally do what you want. Repeatedly call ls in the local directory to find a result symlink to a location in the Nix store. Result bin icat is the executable build previously. Success. So the result is here. That's the program. Result bin icat is the executable build previously. Success. References, next steps. So probably package parameters and overrides with call package. I want to do this. And then I'm going to do file sets. File sets is going to be really cool because there is this, I want to work on this. So this is a tracking issue. Remove all source entries that unintentionally include their own. This is a great way to contribute. And good first bug skills, printable tracking, and architecture. So in Finisal is here too. And Philip Taron. So all of these files, and you can like, and this is, so note that we can use the lib file set library tutorial also to fix this now. Okay, that's my goal, I guess. This would be really cool. We really do some, contribution besides the syntax stuff I found. This would be cool. All right, so that's it for now. And I'm going to be, next thing it will be working with local files. No. Package parameters and overrides with call package. Should it do this? How long is this? Just a second. All right, bye-bye for now.